Attention, please. The show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Okay, hello you guys. Can you guys hear me clearly? Hello Rakuna again. Hello Cảnh Đệ. Hello Kẹo Gaming. I'm not sure why today we have 26 people, but in the live stream it's only have 4. Okay, I guess we need to start. So have you guys joined the Leetcode contest yesterday and today? We have 2 contests. I'm not sure that if you guys can join or not. For this morning contest, I found the 4th questions is hard. I tried to implement, but I failed. For the biweekly contest, I can solve all the problems. So the first problem is easy. The second problem, I need to use the hash map and need to read by a short increasing order. For the third question, need to use dynamic programming to solve it. For the medium problem, we need to use dynamic programming to solve it. For the last question, we need to by research. We need to by research to solve it. This is clear. Okay. So so today we go on to continue with the mock assessment. Okay, because for the Google Onsite interview, I already solved all the problems. So Facebook as well, and only have Amazon. But Amazon problem is quite easy. For the Microsoft problem, it's even harder compared to Google and Facebook. I'm not sure why Leetcode prepares for Microsoft Onsite interview with the hard problem. A lot of hard problem. So let's get started. We will show the Microsoft Onsite interview. So when I show the problem, if you guys have any questions, feel free to ask in the live streaming comment. I will read and answer your question. Okay, today we have 4 questions. As normal, I will read the problem clear out loud, and then I go through examples so you guys can understand clearly. Then I will implement it, and I will tell the time complexity and space complexity. Okay. The first question is, given an integer array num, find the contiguous subarray contains at least one number which has the largest sum, return its sum. A subarray is contiguous part of an array. Okay, so the problem asks, given the integer array, right? Find the subarray, right? Subarray contains at least one number which has the largest sum and return its sum. For example, like this, if you for -1 to this one has the sum like 6, right? So only this subarray have the maximum sum. Other subarray, like for example, like this, if you have -4, it's not large. Okay. For this one, it will return 1. For this one, it will return plus all of them together. So it will be 23. Okay, you can understand, right? This is a very classic problem. We can solve it by use can algorithm. Can algorithm here. Very classic problem. So what we need to do is that we just plus. So okay, I have the first. I need to initialize the first answer like this. Okay, because this is always greater or equal to 1, so I don't need to care the sk. I iterate from my num here, right? I have the sum so far equal to 0, and I plus with sum so far with the x. So, and I compare my answer here with the sum so far, right? If my sum, right, is less than 0, right, I will reset it to 0. Finally, I will return my answer. Why it works? Let's go through this example. So we have a answer initialized with -2, right? And sum so far will equal to 0. Then we plus with -1. So sum so far will become -1. And we update the answer the same. And since the sum here is less than 0, so we we reset it into 0. Okay. For example, like this, right? We have sum so far plus with 1, so it becomes 1. So we compare our answer with sum so far, so it becomes 1 here, right? And sum so far is positive, so we don't need to reset to 0. We continue with this one. We plus with -3, so it becomes -2. Okay, so our answer keep the same. And since this is -1, we reset it into 0. Okay, and do the same with 4, right? So we update the answer to be 4. Okay, and continue with this one. We plus with -1 become 3, and answer don't need to update, so we keep 3. Okay, when we mix 2, we plus with 2, so it become 5, right? So we update answer so far to be 5. Okay, then we mix 1, we add sum so far plus with 1, it becomes 6, right? And we update the answer so far to be 6. Then we continue with the -5 here, right? So sum plus -5 become 1. So don't need to update the answer. Continue with 4. So we plus 5. 1 plus 4 will be equal to 5 here. So answer keep the same. So finally we return our answer is 6. Yeah. Seem straightforward. So we have 6, 1, 23, correct? Okay. So the time complexity for this problem is O(n), and the space complexity is O1. Okay. Seem easy, right? Seem easy. Seem easy for the first question. Okay. Let's move on to the second question. Suppose you are at a party with n people, right? Label from 0 to n-1, and among them there may exist one celebrity. This is enter with nickname, right? Celebrity. Okay. What is celebrity? Celebrity, something like famous people, right? Okay. So we have a party, right? We have n people, and there may exist one celebrity. The definition of celebrity is that all the other n-1 people know him, her, but he, she does not know any of them. So celebrity is that n-1 people. So it means that all other people know him, her, but she don't know any of them. Okay. You want to find out who the celebrity is, or verify that there is not one. The only thing you are allowed to do is that to ask questions like, "Hi, are you B? Do you know? Hi A, do you know B?" To get information about whether A knows B or not, you need to find out the celebrity or verify there is not one by asking as few questions as possible in the asymptotic sense. Okay, so you are given a helper function no able with AB would tell you whether A know B or not. So whether A know B or not, okay. Implement a function find celebrity. There will be exactly one celebrity. If he or she is in the party, return the celebrity ID label. If there is a celebrity in the party, if no celebrity, return -1. Okay, for example, like this. Okay, so this is the graph, right? I'm not sure. This is a graph, but this input for the test case. But in our function, they hide this graph. So we don't need to. We don't know this graph. We only access through the API like this. Okay, there are three person label. So they given us the number of people. Okay, with the ID 0, 1, 2. So graph this equal mean that I know person trait. Otherwise mean does not know person trait. The celebrity person is the person label as one. Because both 0 and 2 know him, right? But one does not know anybody. So it give us that n less or equal to 100. And the length of it. So the number of s may up to n multiplied by n plus 1 minus 2. Something like this. Number of s. Okay. So so how do we find the celebrity efficiently? Okay. So for the brute force solution first, what's the brute force solution? It as we try for I in range n, right? We check if I here is celebrity, right? So how to check if I is celebrity? So we need to loop j n time again to check that right, check knows j know I or not. So if all of other people know j and I here don't know j, right? So we will return i.e. the celebrity, but this solution will take on square. So let me implement it further, right? In range here, okay. So I look other people. So let's make it for candidate. Okay, candidate. Okay, and other people. Okay, for other people in range of n, and our candidate here is different to other. Okay, so if knows other people know candidate, okay, so we increase something like score, something like this, 0, okay, score +1. Okay, so if we check again candidate know other or not, so we expect candidate don't know other. So if no other, right, we minus score something like this. Finally, we check that if our score need to be n-1, which means that n-1 other people know that the candidate. Okay, then we return our answer here. Otherwise, we return -1. So this is a brute force solution. Let's check if it works correctly or not. Yeah, can. Right. But this take n square or n square. Let's make it. Yeah, actually that they limit the time the time. So even it have only 100 and we do the n square, but TOE. So we need to find a better solution. So we need to find a better solution. Then better solution than n square. Okay. So need to do better than n square. It sync the follow up. The maximum number of allowed ABI nodes is 3 multiplied by n. But we do n square here. Could you find a solution without exceed the maximum number of code? So actually that they want us to do on. They want us to call n. Okay. So how can we solve it in on? How can we apply some topology sort? Something like we have in degree, right? In degree of vertex. So we have 3 nodes here. Okay. So for this we need to on square as well. So we need to check for n other nodes. For n nodes, we need to iterate for n nodes, and we need to check the candidate with other as well. So if you take n square as well, how can we do it in on? The what's special here? What's special here? What's special here? What's special here? Do we have any special here? So the celebrity has in degree 0, right? In degree, right? In degree should be n-1. In degree should be n-1. The celebrity should have in degree n-1, right? For other have is there any case that other people also have in degree n-1? Can, right? For example, that if we have another arrows, something like 1.2 here, so this is in degree also n-1, but the out degree is 1, and the out degree is 0, right? It should have the out degree is 0. So out degree is 0, right? So we can we check if E has 0 out degree? Is celebrity? It's harder. Hi, Hiếu. This question is not easy. So I guess we need to come back later. I need to come back later. So let's move to the question 3. If we have time, we come back later. So assume the following rules are for the Tic-Tac-Toe games on an n-multiply board between 2 players. A move is guaranteed to be valid and is placed on the empty block. Once a winning condition is reached, no more moves are allowed. A player who succeeds in placing n of their marks in a horizontal, vertical, and diagonal rows win the game. Implement Tic-Tac-Toe games class. Initialize object with side of the board and move row column player. Indicate that player with ID player play as the cell row column on the board. The move again to be valid move. Okay, so what's the output we need here? So we initialize the board structure, something like that, and we need to return when the player, right, put a cell on the board. So we need to return 0 if no one win, or 1 if player 1 win, 2 if player 2 win. Okay. So we have n here. Let's equal to 100. So how to check if a move is win or not? A move guaranteed to be valid, right? And E already placed in the empty block. Once winning condition is reached, no more moves are allowed. A player who succeeds place n of their marks in the horizontal, right? Full the horizontal or vertical or diagonal rows win the game. Diagonal here include anti-diagonal as well, right? Anti-diagonal as well. Okay. Okay. So how to solve it? For example, like this. So we need to something like we need to store. We need the proof fork solution, right? The proof fork solution is that we have first we come with the solution one, which is proof fork. So proof fork solution is that when the player plays a cell, right? So we need to check, like we need to do the vertical check, horizontal check, and diagonal check as well, right? So it will check each time move here. It will check O of N. N here is the side length of the board. Okay. So this is a proof of solution. Can we show it optimize? To show it optimize, I think we need to something like we need to count by rows here, right? We have n rows here. So when the player one plays X, something like that, we count one, right? We count one. So when the player two plays play 0, something like that, do we need to count? Yeah, we can count. You can count the player 1 and player 2 by each row here. So by each row, right? By rows and by column as well. So when the user like push on this, right? So we check. We increase the rows and the horizontal by 1, and we check if them are fully matched. If them are fully matched, we return the player who win. Yeah. So by using this, we can achieve in O1 in time complexity. Okay. So let's implement it. So okay, I need by rows as well. Count by rows. I have totally this one rows. Okay. Count row for X. Right. Count rows. Something like I have a rows X, something like that, and rows of Y. So I don't need this is 1 or 2, right? So actually that I can use the index. Use the index. So for the player 1, I will use index as 0. Okay, player 2, I use index as 1. So I have 2D dimensional here. Okay, something like this. For player 1 and player 2, do the same thing with the column. I have the same like this. Okay. I need to store the diagonal as well. Diagonal. For the diagonal, I just store the one element only, one flag, to store the count of diagonal as well only. So I have something 0 0 for 2 player and anti-diagonal as well. So this I call main diagonal, and this is anti-diagonal. Okay. So when I initialize the array like this, then I just count. So when I push player play, right? So the problem guarantee is a valid move, so we don't need to check anything. So we just we have the player, right? Player index will be player -1 as we define here, right? Okay. So we just increase rows of row here of the player ID index plus 1 cell dot column player index of column plus 1, right? And for the diagonal, we need to check if it's in the diagonal or not. For example, this case it's not in the diagonal, right? In this case, it's in the main diagonal and in the anti-diagonal as well. So we need to check if it's in the main diagonal. When it's in the main diagonal, so we can see that the rows and the column is the same. So if row and column are the same, right? So we increase the main diagonal of player ID index plus by 1. Okay. We need to check for the anti-diagonal as well. For example, like this, right? So it belongs to the anti-diagonal. So it's something like the absolute difference between the row and column is n, right? You can see n minus 1. Okay. In this, right? So the rows is 2, the column is 0. So the absolute difference between them are 2, which is n minus 1. The same with this and the same with this, right? So if the absolute difference between the row and column is n minus 1, so it belongs to the anti-diagonal player index plus 1. Okay. So if win, right? If they win, it means that if the rows of the player by rows here equal to n, or right, column here equal to n, right, or the main diagonal here is equal to n, or the anti-diagonal here is equal to n, right? We just return the player who win, which is player who win, right? Otherwise, we return they are not win, no win yet. Yeah. So let's check. N here is not defined, so I need to store the n as well. Okay, seem correct. So let's run. Wrong answer. Why? Why wrong answer? Let's check my code again. I have a rows here, column here, main diagonal, anti-diagonal. Player index will be player minus 1. I have a rows plus column plus equal, right? Main plus absolute difference is n minus 1, right? Anti plus if rows column main or anti return player. Yeah, seem correct. Why? So let's debug to know why. But this example return to return correctly, right? But this not return to correctly. So I guess we need to draw. I guess we need to draw to know why. So we have the bar of 4, right? Okay. So move first row column and player, right? Okay. So we have a move 0, 0, 0, 3, 0 here, and column 3. So this is 1. Okay. 3, 3, 2. 3, 3, 2. 2. Okay. 3, 0, 1. 3, 0, 1. Okay. 0, 0, 2. 0, 0, 2. Okay. 2, 1, 1. 2, 1, 1. Okay. 2, 2, 2. 2, 2, 2 here. Okay. 1, 2, 1, 1, 2, 1. So this should be n, right? Why it doesn't equal to n? Sub 2, 2, 2. So what's the problem here? What's the bug here? Why have bug? What happened to rows here? So let's bring to check the cell of anti-diagonal. Not sure this one is correct or not. We get the absolute value, right? Oh, it's not the absolute value. The total sum of them, right? For example, in the middle here, right? The total sum of them, not the absolute value. The total sum of them, not the absolute value. Yeah. I think it can work now. Yeah. So to check the diagonal, we need to get the total sum of row and column. If the sum of row and column is equal to n minus 1, it belongs to the anti-diagonal. Okay. Anyone have questions? So as I said, the time complexity in initialize EON, right? For each move here, so I only increase, right? No loop here. So the time complexity is O1, right? The space complexity for the initialize function will be ON. So this problem is quite easy, not very hard. Okay, let's move on to the question 4. Okay, given a linked list, reverse the nodes of the linked list k at a time and return x. Modify list k a positive integer and less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left out node in the end should remain x as xa. You may not alter the values in the list node. Only nodes themselves may be changed. Not sure I understand. Reverse k, right? So reverse the nodes of the linked list k at a time. For example, 2 here, right? I need to reverse 1 and 2 together to become 2 and 1. Okay, and do the same with this one. I reverse 4 here and 3 here, and the last one is the left out, right? It don't have enough k elements, so I left it as a left as a. Okay, so I return 2, 1, 4, 3, 5. For example, like this, I will reverse to become 1, to become 3, 2, 1. And this one is enough, not enough k element, so I return it as xa. Okay, so I have the size here is less or equal to 1 to 5,000. and the k here less than or equal to psi here. Could you show it in O1 extra space? So if we if we don't use the if we don't want to show it in O1 extra, if we use in solution 1, right, we use like ON additional space, something like this. So we just add them all the arrays, right? Iterate the head of linked list, right, and add to the array, and then do reverse them, and then reverse them, right? Keep consecutive elements, right? Something like this, and then we return. We have the final array, and then we mark the linked list. But the interviewer should not expect this solution. This solution for proof force. So interviewer will expect the second solution. Okay, we need to do it in place. In O1 in space. Okay. How to do this? So we just so for example that 1 2 1 here, right, 2 here, right, 3 here, right, 4 here, right, 5 here, right. So I have head here. I need to iterate 1 here and 2 here, right? So I need to mark this one to be head. For 2 element is not intuitive. So let's mark the KE3. Let's for example KE3 is more intuitive. Okay, so head here, right? We need to, if we jump K, right, head here we jump 1 2 3, then we have the next here. The next head here is point to the node 4, right? So we keep continue to process. Then we need to return the reverse linked list of this one, and then we need to return the reverse order of this linked list, right? And then we point to this one. So the idea is that we iterate k time, right? So it become point to the next one. So we should keep the previous as well, right? The previous node. So we have the current node like this, and we keep the previous node, right? So so we need to reverse this one. So we need to write a function to reverse a linked list, right? Given the node here. So we may have the breadth here, right? And the next head here. Okay. Right. So we can set the pre-doc next equal to noon, right? And we need to keep the the head here, something like this. So this is called the next head. Next head. Okay. So for the current head here, we have the head here, right? And this one, the ref here, point next is to none here. So we have this or linked list, right? We split them. Okay. So now we just write a reverse function, reverse linked list, something like this, and push the head. So we need to return the reverse linked list has a header, something like this. So after we have the new head of a linked list, it will become like 3.2.1, right? So we have this one. We need to return the head as well, so we can point to the next. So our function here needs to return like a head, new head, right? New head and a new tail, something like this. Why we need the tail? Why we need to the tail? Because we need the head here, right? We need the tail here to point to the next one, right? Yeah, seems work out. So let's implement it. So why cannot type? Oops. My keyboard has a problem. Oops, why cannot type? Oops, why I cannot type? What's the problem with my keyboard? Okay, so why head here? I need to like I said you before, right? I need to have the the original head, something like this. This will become head, and I iterate k time, right? Need to iterate k time. I go to jump to the next head and plus with k. I the count here, right? So I need to store the prep as well. So the prep will become to head, right? So I can after I jump k time, so I will have this result, right? So head here now is a 0.24. So let's original head, something like that. And this is the next head here, the head. Okay. So what happens if I here is not enough k, right? So if I here is k, so it means that we found enough and enough k element, right? If we found enough k element like this, right, then we will do reverse. If we don't found enough k element, right, for example that we have the left one here, so it will become one here, right? One here. So we just point them, point them. Okay. So we I guess we need to have the dummy head for easy to manage. Okay. If we have enough k element, then reverse them. But firstly, we need to k here is greater than 1, right? greater or equal to 1. So it at least it have one jump, right? Because k equal greater or equal to 1, so it at least have one jump. So the prep here will always not null. So we can set next is none. It's fine. Okay. Then we just reverse the linked list from the original head here, right? So our reverse linked list will return the new head and the new tail, something like this. Actually, that new tail here is equal to actually that new tail is equal to this one. So actually, don't need to return the new tail, right? Don't need to return the new tail. Just the new head is enough. Okay. So we do the reverse the linked list here. So we have the new head. New head will become to like this, right? So we have curl head dot next. We point to new head. Curl head dot next. And the new head here is 3 here, right? And we point. So we have the dummy, right? Dummy currently dummy like this. You could point to 3 here, point to the new head here, right? So we have the tail here. The tail here is equal to new tail here is equal to original header. Original head here. Okay. So we point to the next one. So actually that this one actually that we don't I guess we don't need to dummy head. We even don't need the dummy head. We have something like the answer will equal to none first. So we only set in the first time, right? So if the answer here is none, we set it in the first time, right? For the first time, right? This is our answer. So we need to return 3 here at the head of our answer. Answer head, something like this, for easy to understand. Set for the first time only. Okay. Remove curl head here. Okay. So we have the new tail here, right? New tail here, which is 1 here. So we need to point to the next one. And the next one we have a head here, right? So let new tail here dot next point to the head one, which is it's not head. Actually that this will reverse. So we may have the prep. We need to have the prep the tail, the new tail. Okay, we store it as global. So we need to point to the new head. If the answer set for the first time, right? We set this one. Else, we have the new tail point to the new head. In case not enough, k elements, not enough k elements, something like this. So we return the original head, right? The original head. So we need to point to the original head. So let's review this one. So new head here will equal to the original head. New head here equal to original head, and I guess we need to do this the same. This is the last one, so may have 2k, right? This one may happen. So we set our answer here. Otherwise, we have the new head here, the new tail here. So we will point to the next one. Finally, we just the new head here will be original one, right? Because it doesn't do anything. It's on the original one. New head will be original one. Okay. We point. Okay. I guess it works. So let's return the answer. A bit dirty. A bit dirty. Let's reverse it. So to reverse a linked list, we just like I will draw you so you can see clearly how to reverse a linked list. To reverse a linked list, so we something like we have this linked list, right? To the null, right? So we something like we have a stack, something like this. So this is the new head, something like this. New head will equal to none first, right? Okay, so when we process this one, right? So we need to store the next first, and then we have the head here. Dot next, we point to the new head, right? We point to the null. So it means that we put the head element to this, and head element will point to the previous one, which is new head, right? And the head will point to the current node. Do the same for this one. We put this one, and this one we point to the new head, and new head update to this one. We do the same until we finish to iterate the whole linked list. So this is the new head, right? So our new head will in the reverse order. So new head here equal to none. Y head none. You need to store the next element will be first, and I change the point to my new head, and then the head here will come to next. Okay, and finally I just return my new head here. Okay, let's run. 5, which is not correct. Okay, so let's go through one by one. Let's check if it process. Okay, first is process 1, second will process 3, last one process 5, correct? Okay, so we have the original head will be this one. I store the original head, and the prep is equal to none first, and I iterate k time. So it will jump to this and jump to this. Right. So after I process the first one, right, original head will be this one. The prep will be the prep. Because I in this case I have k equal to 3. So I mean this example. So original head will point to this. The pre-head will point to this, and the head will point to 4 here. Okay. Okay. This is what I did. So if I found enough k element, right? Enough k element, I guess we need to draw let's draw for easy to see. Not sure in the interview they allow us to draw or not, because we interview online. Not sure all the interview they have the whiteboard for us to draw. Okay. Okay. The first one I will store the original. Right. This is original head here. Okay. Then original head here equal to head here, right? And I process k time. So this become the head, and this one become the breadth. Okay. Right. So I found enough k element. So I reverse do reverse with the original head here. But first I set the breadth here, right? Point to the next will equal to none, right? So I can have this linked list, and I do the reverse in this linked list from original here until breadth here. Okay. Then I return a new head, right? The new head. Okay. After I have the new head, which is 3 here, point to 3 here, point to 2, point to 1, right? So I have the new head here. I have a new head here. So if our answer head is initialized in none, right? Set for the first time, right? We set head. This is answer head as well, right? For first time, right? So answer head become to new head. Else order. Okay, and I store the tail, new tail will equal to original head. It means this one. This is the new tail. This is the new tail. New tail. Let's bring. Not sure it's correctly or not. Value. New tail. Right, new tail will equal to 1, right? Correct, right? Right. Okay. Why I need the new tail? I need the new tail to get the new tail point to the next one. Okay. So okay. Then I continue to process the while loop here. So I will I will have the original array. Will original head report to this. Alright, original head report to this, and I loop it up to k time. Now our head here will equal to null. Our head here equal to null, and the breadth here will equal to this one, right? And this k, I here not enough k element, right? So I have the new head here will equal to original head here, right? And I do the new tail here, right? Point to the new head, which is original head here, right? So it will be correct. It should correct. I think it will correct for the second test case. Not sure why the first test case is incorrect. Seems incorrect. So we have something wrong. Second test case also incorrect. Why? So let's debug. Debug. Okay, firstly, and we iterate k time, right? So now we have the breadth here, dot value here equal to 3, right? 3 here, correct? So, and head here equal to 4, right? Correct? And the original head here will be 1, right? Correct? Okay. So breadth point to next will equal to null. And we do the reverse the linked list here. Reverse the linked list here. Reverse the linked list here should be correct, right? New here. Next here. Point to the I have an update. No one point out my error. Will head will equal to head. Okay, 3, 2, 1, 4, 5, correct? Okay. Let's run all the test case. So 2, 1, 4, 3, 5, correct? 1, 2, 3, 4, 5, 3, correct. Okay, seem correct. Okay. This is hard. A lot of stuff. Said that speak English. Speak Vietnamese. Actually, that we have a international audience here, and I want to speak English to improve myself as well. So, Ida, do you guys have any questions, or do you guys want me to explain the algorithm again? So the time complexity for this algorithm is O(n). That's by the O1, because I don't create additional arrays. So you need to know the algorithm to reverse the linked list, and we just reverse k by k. So if you guys don't have any questions, I will go back to question 2. Why ON square cannot pass? They limit the time. Can we solve this one in ON? How can do you guys have any ideas? How can we solve it in ON? It need to have our degree 0, right? So how about we check 0 to 1, 1 to 2, something like that. N minus 2 to n minus 1. Okay. So if there is a relationship between them, we check something like 0 with 1, right? And 1 with 0. So if this one, so if 0 no 1 and 1 no 0, right? If 0 no 1, so it means that 0 not a celebrity, right? Because it shouldn't know anyone, but it know 1. So 0 is not a celebrity. Do the same with this one. If 1 no, if 1 no 0, right? So I don't need to check this one. So I have a case 1. If 0 no 1, 0 not a celebrity. Case 2, 1 no this if it return 2, right? 1 return 4, something like that, right? 0 potential celebrity. Let's try. This problem is harder. If knows AB, right? We have the candidate here. So if A no B, right? We may have some in degree as well. So in degree of B plus 1. And the candidate don't include A. because like I said here, 0 no 1 vision 2, then 0 not a celebrity, right? And in degree of B here, B plus 1 because someone pointed them. How about return false any information? 0 here potential celebrity, right? So 0 here potential celebrity with set A here, right? And 0 no 1 false this potential celebrity. So let's bring to see any special. So in this case, I have I check 0 to 1 here, right? Because 0 no 1, so 0 not a celebrity, right? And in degree of 1 is 1. Okay, I do the same with 1 to 2. I do the same with 1 to 2 here, right? So 1 here, if you return false, so A here, so if you 1 here, is potential a celebrity. I had the candidate here. One, no, 2 or not. So this one can potential. Okay. So we need to check 2 and 0. If I need to check, I need to modify with the n. So 2 with 3 modified by 3 become 0. So I check this one as well. Any special? Still 1 is the candidate, and the in degree of 0 of in degree of 1 is 1, because we don't have enough information. Hard question. Hard question. Microsoft question is hard. So we have the after it gray here, right? So we may check how about we check opposite sides like no of B and A in degree of A plus 1. Candidate will obtain with if A no B, right? If A no B, then in degree B plus 1. Our degree. How about we store our degree as well? If A no B, right? So our degree A plus 1, right? A no B, our degree plus 1. And if they don't know the candidate, maybe A. maybe there are no S. Oops, this is equal to N. What? Suppose among them there may be 6. Definitely that there are other. Now you want to find out who celebrity or website and no one. The only thing you need to allow is that hi, do I know you? Hi A, do you know B? To get information, you need to find celebrity, asking a few questions if possible. You are given helper tell A, no B or not, implement 5 exactly 1. Exactly 1, huh? There is only 1. A, no B. Otherwise, it can we should have stored the candidate that bring the in degree and out degree to check what's special here. So we have in degree of 0 E1 here, right? Because 2.0 here, and out degree of 0 E1. For in degree of 1, we have in degree of 1 we have 1 because I don't check the opposite side. It's quite hard. So let's see the hint. I want to see some hint. Oh, I guess this is the premium problem. This is the premium problem. Premium problem. I guess I need to see the hint. The best hint for this problem can be provided by following picture. A, no B, false, meaning that B cannot be the celebrity. Any other people? I mix this expression. I mix this comment. I mix this comment. So I have the candidate here. So first of all, I will add all of them. Candidate here. All of them into my set here. Okay. So if A no B, right? If A no B, A no B, then A should remove. I should remove A. A not a celebrity, right? Because the celebrity don't know the celebrity don't know any other people, right? Otherwise, if A knows B. Okay. A doesn't know B. If A doesn't know B, right? Then B not a candidate because there is one person doesn't know there exists one person doesn't know B, right? So this cat B. So when I traverse the whole this one, I can have the last candidate. Let's bring candidate. Have one element. When I traverse like this, right? I process A and B. So it may decast one of them, right? One of them. At least decast one of them. How about I add the reverse question like if knows B and A. If like this, right? I will discard, right? Discard the opposite A, something like that. Then I guess for this one, right? If you discard at least one element, I even don't need this one. So after because this one, right? It at least discard one element because I process from 0 to 1, 0, 1 to something with the n minus 1, right? So this one is should discard 1. I iterate n element. I iterate like this, right? How about it's discard 0 is correct, right? How about this? Cut 1 is no problem. But when to discard 1 here, 1 to discard 1 again. So I exit 2. So I think I need to do reverse order as well. So in this one, right, I discard 1. In this one, I discard 1. So let's do reverse order. Okay, finally return if length of candidate equal to 0, we return -1. Otherwise, we return candidate of the first element. Wrong answer. How about this case? So so it means that we have 0, 1, 2 here. So 0, 0 is 1. 0, 2. This is the adjacent matrix, right? Yeah, adjacent matrix. Adjacent matrix. So 0 0 E1 0 1 0 1 E1 0 2 E1 1 0 E1 1 1 E1 1 2 0 2 0 2 1 2 2. Okay, in this case, if this case should return the one here is the celebrity. Why one here is celebrity? Because when I check A no B or not, right? A no B or not. So if A no B, A not a celebrity, and A no B here, so A not a celebrity, correct? Right? And one I check with two. One I check with two. If one no two, one not celebrity, but it's the else, right? So it means that because one here doesn't know two, so two here not a celebrity. And finally, I do with two with zero, 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 right? Two with zero. Okay, two no zero, not no. So zero not a celebrity. So one is celebrity, which is not correct. However, I add two direction. It's -1, but wrong syntax K. Wrong this syntax K. I have 0, 1, 2, 3. Okay, 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. Two 0, 2 1, 2 2, 2 3, 3 0, 3 2, 3 3 3. Okay, so in this case, why I put 1? Okay, I check 0 and 1. 0 and 1, right? 0 and 1. So 0 not a celebrity. 1 with 2. 1 or 2 or not? No. 1 doesn't know 2. So 2 not a celebrity. Maybe I should check the remain. The remain candidate with other. Check the remain candidate with other. Okay. In this case, I have 3 here. Okay. 3 I check with 0. Do 3 no 0? Yes. 3 not a candidate. So I return 1 here a candidate. Maybe I need to verify again. I need to verify again. Need to verify again. Need to verify again. I guess this will work. I have some candidate. I need to verify them again. If why? I need to check if they know any other people. I need to for other people. It's different to this one. And candidate no other, right? So it should remove. If don't know other people. So I have the copy. Set up remove. Right. Think it no other people. And then I drag. Finally, I check if my can set return -1. Otherwise, return the first one. Yeah. It's hard. B cannot be celebrated. A can be celebrated. Let's move on. A cannot be a celebrity. Alright. C can be a celebrity. Let's move on. Oh, so they iterate like A with other. Well, if we understood the gist of Apple idea, you can extend it to find a celebrity that can possibly be a celebrity. Why do we say candidate? That is for you to think. This is clear with the approach to find answer. However, there is some information that would still remain to be verified without what we can obtain the answer with the celebrity. To get the stake in the ground, we need to some code to know the AI. So after we do like linear scan here, I like we don't do like this. A here. White greater than and 1, right? Because it should have only 1. can here will equal to can set remain. Okay. Something like this. So for A in range of end, B will be B in range of n plus 1 and if A knows A no B, right? If A no B, then the candidate here, A cannot be a candidate. No, B cannot be a candidate. B cannot be a candidate. Not in the candidate, we return. Continue. I guess we optimize something. We already optimized something. How big will pass? Length. List. 0. That's one correct. DOE. Wrong itself. So 0 and 1. And 0 no 0. 1 no 1. At least 0 I check 1. Yeah, 0 and 1 in the candidate list, right? 0 and check 1. So E0 no 1 doesn't know, right? So this cannot a candidate. E1 here no 0. And we should not skip this one. So it's n square again. So thank you guys for watching, I guess. Hello Sang-hun, but I think I would like to end this live stream now. Actually, that question Chui Khoa had, I cannot solve it. Okay, thank you guys for watching. I would like to see you guys on the next live streaming. Thank you. Bye bye.